figured yesterday? No questions? Okay. You don't have any questions, that's fine. You ready to take the test on the DHCP? I guess not. Let's see. Chat. What's the name is there? Let's see. Kyle. We have some people that are not on the call yet. And basically the people who have trouble. Okay.
I know Brandon and Ian said they weren't going to be able to make it today for personal reasons.
Okay. Any question about how to configure a DHCP, the router as a DHCP server? And how you configure DHCP server and you allow it to provide services for clients on a different subnet with IP helper? Any question about that part?
No, sir.
Okay. How to do pool? It looks like everybody knows. We already talked about this. The lease. Let's see, what is that? So that's a quick review. We always start with IP DHCP excluded address. So if you want to make it this one as a DHCP server, so you do excluded address all the time. You can put a range from 1 to 9 or 10, whatever range you want to put the exclude. Then, if you want to add individual address to exclude, you can do that. For example, this is the last address on this subnet they excluded to 192.168.10.254. Then they create an IP DHCP pool LAN pool 1, which is to support this particular LAN. And of course, you can put a default router, which is the interface, the IP address for this interface, DNS server, which is right here. They say .6 over here. They say .5, so it's like a typo. Now, what you need to distinguish is, which is a lot of people have mistakes, especially in your class. You cannot put the default gateway outside your subnet. This address here always need to be on the same as this line right here, the same network ID. This is the default router, basically is the IP address of this interface. So all the clients need to have the same default gateway, which is this address, 192.168.10.1. Now, some people from the previous test, they put the IP address like 192.168.2.2 for every single VLAN. That doesn't work this way. And this is like a basic information from Cisco One. They still have the same issue. Now, the DNS doesn't matter. You can put DNS on a different subnet, different city, doesn't make any difference. Some people, they put 8.8.8.8, whatever. But, and you can put multiple DNSs. You put DNS server 192.168.11.5, then you put space, then you put another DNS. Now, the rule for DNS, if you're trying to resolve local devices in your network, then you can make your own DNS. Some people said, okay, I just need a DNS to resolve, to go to the internet. In this case, you can use Google, you can DNS, you can use somebody else's DNS or your ISP, and that will be fine. And of course, also you can configure the domain name. Okay. So that's part right here on the configuration. Now, this is all troubleshooting. One thing I should mention here, well, suppose I have a multiple VLAN, like the example I gave you, and you put the DHCP server on a server, and your DHCP server on different subnet. So how people from a different subnets are gonna get an IP address? And that's what we need to configure, the IP helper address. So you go to the interface of that VLAN or that LAN that need service, and you go IP helper address, and you point it to where is the DHCP server. And that's basically what they're talking about here. We have DHCP server right here in this subnet, and those guys need the DHCP server. And some in the Microsoft terminology, we call it DHCP relay, DHCP version 4 relay. So basically, your DHCP server is not on your subnet. And especially on IPv4, when this PC wakes up, it sends a broadcast looking for a DHCP server. They send like a MAC address, FFFF. That's the broadcast MAC address. Then, in this case, it's not going to see any DHCP server on his subnet. Because why? Because there's none. The DHCP server is in this subnet. So how are we going to provide services for the client on this segments right here? So what we need to do, we need to go to this interface, which is gigabit 0/0 in this case. And we're going to tell them, okay, we're going to help you find the DHCP server, and we need to point it to this guy here, okay, to this address. Because when this guy sends the broadcast is going to be stopped right here. Cannot go beyond this interface. Because this segment here has its own broadcast domain. Now, to allow to communicate with the DHCP server, we need to put IP helper address on this interface, and we're going to point it to this DHCP server. And that's what we call it, DHCP v4 relay agent. Now, of course, you can also provide services for DNS, for FTP server, for TFTP, and all that stuff. That's an option. They call it scope option. Okay. Now, of course, the DHCP server on the packet tracer, it's okay, but it's not the same as the one when you go configure it on a DHCP server on Microsoft server. It's the same concept. Basically, create pool or scope, and any extra information you need to give the client, we call it scope option. Okay. So that's what we're going to do. All right. If you don't have any question, we'll go further and finish this one here. And that's what we talked about, the IP helper address, which is, this is the gateway to allow it to communicate with the server. So, oh, this is correct right here. I don't know. Okay, so the server is 1.6, 192.168.6. When you go to IP helper address, okay, you're gonna go to 190, you point it to the 192.168.11.6, which is the DHCP server. And that's if you want to put this command if your DHCP server outside your LAN or your network. Now, of course, there's an options. DHCP version 4 is not the only server that the router can configure to relay by default. IP helper address command forward the following 8 UDP services. For the time, port 36. This is another server for authentication. You can point it to that. The DNS, DHCP boot P. Usually this one is also on port 67, which is this is boot P. This is it was before DHCP for diskless devices. So we use a port 67 for server, and we use port 68 for client. So this is important to remember these port number. 167 for server, 68 for server. Yeah, now we have port 69, which is TFTP server. NetBIOS name service 137, 138. We don't use those anymore. But this is very important to remember. 69 and 67, and of course 53 for the DNS. Those are very, very important port numbers to remember. Okay, let's see. We did the configuration on the client. Now, if this is the office, okay, and you have a router in your office and connected with DSL, now this interface, you can configure it on auto, okay, and it's gonna get an IP address from a DHCP server. Now, to make a Cisco router to communicate with DSL is really difficult because you need to, because what's in here? The DSL has RJ11. It's connected to the phone line. And if you have like a Cisco router, like the one we use, you have to have a special interface here to interface with that DSL. Otherwise, you have to configure it, and it's a lot of work. That basically you need to combine this interface as physical one to a logical one. And this is what we're going to do in Cisco 4. But that's a hard thing to do, but it's okay. So bottom line is on this interface, you can get an IP address automatically from the ISP to assign one automatically over here. And you can see it like when you go on the small routers, like small office routers, like Linksys or any of this stuff. And you're going to have like a WAN port on your router, and you connect it from the cable or the DSL, whatever. And you can see, if you go inside the router, you can see they have a DHCP, you can obtain address from the ISP dynamically. Now, if you have a little small business and you don't want that, because some people put like in their business like cameras and whatever, and they want to access resources from the outside, and you don't want this particular address to change, then you could tell the ISP that you need a static address. And I think they charge you extra money for that, but usually it's designed for business. Okay. Question at this point. You understand what I mean by obtain address from the ISP over here? I think the next slide. And that's how you configure it. Interface, gigabit, 0/0, IP address, DHCP. So that's how you configure it. Some people put IP address auto. So you can do that. Now, this is what you have at home. You're going to have Linksys router, whatever you go. You need to go to the WAN connections, and they have an arrow over here, and you can set it up. One of the option is automatic configuration DHCP, and if you click on here and the arrow, there's another option for static. Static means what? You get static address from the DHCP's company, and that address is never changed. So this is very, very good for business. Like if you want to access resources from outside to inside your business, you need a static address. Okay, I think this is it for this chapter. Any question before we move on? Actually, we can simulate this one here. Let me see if I have a packet tracer here. This is basically the whole chapter. Okay. So let's see. If we go to let's see. Where is my routers? How about wireless? Home router, right here. This is your home router. And this one's connected to, say, gigabit, and this is going to be connected to the internet. Ah, they don't like that. Yeah, you see, I told you they cannot get accepted. Like, you need a special link. Let's see. Well, let's see. Let's see if they like it. Let's see. No. Enable. 50. Ah. Interface gigabit 0/0. No shutdown. Let's say IP address 192.168.10.1 3 times, that's 0. Exit. Let's see, that changed the status? Yeah, so this is good. So now, if I want to make a DHCP server here, I can go to IP DHCP excluded. Remember that we have to do excluded addresses? I'm going to exclude 192.168. What? 10.1 all the way to 192.168.10.10. Okay. And of course, I need to put we need to make a pool, right? IP DHCP pool, and we need to call it custom or customer pool. Pool. Then we need to say the network, which is 192.168.10.0, and the mask. Now they say you can put /24, but I never work on the packet tracer, but will work in the regular. Let's see. Yeah, it works on the regular router. So just put the subnet mask 255.255. dot 0, and what else? We can put the DNS 8.8.8.8, and I can put 8.8.4.4. That will work. Let's see. No, I guess you have to do one at a time. And also you can put the domain name, whatever you put, cisco.com, all kind of information you can put in here. So you put a question mark here and it give you a list of things that you can do, options. Okay. Exit, WR, okay. Well, let's see, config T, host name, ISP. So we need to pretend, so we need to pretend we are an ISP. Now, if you go to this router here, so this router has already DHCP server on it with 192.168.0. So if you put client here, okay, and this guy, you can put, okay, he's not gonna get because they're negotiating right here. You have Amber, so you can fast forward it. Then you can go to this guy here and go to DHCPs instead of static. Okay, you're gonna get 192.168.0, but we are in 10. So common mistake people do whenever you go, for example, in this router, your internal addresses for your router are supposed to be different from you get them from the DHCP or whatever, from the ISP. Don't put them on the same subnet because it's not gonna work. If I put 0 in here, it's not gonna work. So now, if I go to inside the router, and we go to GUI interface, okay? So this is how your router looks like at home. So we need to go to the internet connections. You see that it's an automatic configuration, which is DHCP. See that? And you have static, wireless AP, wireless bridge, but this is what we need. Now, if you do DHCP, that means what? We need to see that WAN. How you do that? You go to setup, I believe, because it's supposed to give you what address you get in from the DHCP server. Okay, this is for the internal use, which is the client side. This is from the internet. So if you go to think administrator or status, let's see status. Yeah, see the status over here? Oops, I did a boo-boo because I don't put the default gateway on my router configuration. But I get from my ISP, I get this address. You follow? So, and this is an auto. So I need to go back to this and go back to the config T IP DHCP. Oh, question mark. I supposed to do or IP. See IP question mark. Yep, IP DHCP question mark. What am I supposed to do? IP DHCP. I think it's pool. Okay, what pool we name it? Do you remember? Custom. Say it custom pool. Okay, now I can say, let's see, default router. And I need to put 192.168.10.1, okay? So, and the reason why, because I forgot to put it in here to provide to this. So after I put the default gateway, so this guy is gonna get the default gateway, which is this interface. And then this client can go to the internet and can communicate with anywhere. So this is like for a small office setup, if you have a small office. So let's see this guy here. This one is, we get an address, 192.168.10.0100. So can I ping this one from here? Let's see. And ping 192.168.0.100. Now, if I cannot ping it, that means it did not register that default gateway for this guy here. Or I need to restart it actually. I need to restart this one here. See that? Still doesn't have no gateway. So physics. Boom. See that? We need to restart it so we can see. Oh, it still didn't do it. Okay, let's see again. Refresh, no refresh, status. It didn't work, so we have to go back and reset it. Well, how about if we, let's see, if we shut down that interface. Interface config, config p interface gigabit 0/0 shutdown. Let's say no shutdown. Let's see if that makes any difference. Okay, so let's go back here, the ACP, and we need to go to status. Yeah, I forgot to put this one here, the default gateways, that's why. So I need to reconfigure it, but you know what I'm talking about. So I have to redo the whole server, I believe, over here. Let's see. All the ACP server. Well, we can do that. That's fine. So we're gonna put IP DHCP pool, and we call it. Let's see what we call it. We call it custom pool. Remember that? Let's see. Excluded address. Yeah, call it custom pool. Custom pool. IP DHCP pool. Custom pool. Did I put capital letter for pool or what? That's makes a difference. Yeah, small letter. Then you need to put the gateway, which is default. The default gateway 192.168.10.1. We have the DNS server 8.8.8.8, and we need to exit do WR to save it. Now, let's see. As you can see, that makes any difference. Still doesn't make a difference. Set up. Let me put a static here. Let's see. Put it back on. Okay, and status. Well, I guess we should have done it before or change the router. So let's do static. Static address 192.168. Oh, 168.10.2 because we used the other one for the other one. That router. And subnet mask is 255, 255, that's 0, that's fine. Port gateway is 192.168.10.1. DNS, we can use the same one. 192.168, no. We can use 8.8.8.8. Okay, let's see. This is options and then save, I believe. Save settings right here. Okay, let's now what we got on the status. Okay, so now we are good. So now I should be able to ping this client right here. By the way, the client has a different subnet, which is that 0. Uh-oh, we lost the guy over here. How come? Oh, see when you rush things. Okay, anyway, that's a good mistake we did. We put the static address on this guy here, but this is for internal. It should be should be for external, for the router, not the internal address. This is internal. So this is wrong, okay? So we need to go back to this is the internet. So this is good. This is for the network, for the inside, which is correct. This is for the external. Okay, so this is the internal network. I'm going to keep it like it is on the DHCP server. Now you want to change this one, you can, but it's okay. We're going to leave it as default. Usually 192.168.0 or 1, that's most of the Linksys router they can have. Now I can change this one. This is the internet. I can change it to static. And okay, so it's set on static. Okay. So we're gonna do save setting. Gonna take a second, I guess. Now it's gonna take a couple of attempts, I believe. No. Well, let's see. I'm not gonna waste time on this one. Let's do on this guy here. Looks like it's yeah, man. I thought we put DHCP on here, right? Yeah. DSP server, this one is okay. Maximum number usually. This is for reservation if you reserve a MAC address. Maximum number of users. I can put 10. Let's see. Save settings. Let's see. This is still rebooting, I guess. Fast forwarding. Let's see. I don't know why it's not getting an IP address. I must have done something good. I'll tell you what. Sometimes it's stubborn. So I'm going to do this. Whoosh. So we need to go back and get another router. Let's see. Home router. Which one's the home router? Home router right here. You connect it from the gigabit to the internet and from here to these machines right here. Okay. Okay. So now I should get yeah, now it's working. Okay, so we get in now we get in the right one. So how about the GUI? We go to GUI and we go to the internet. The internet is on the DHCP server. So if you go to status right here, still didn't get the gateway because we messed up on the beginning. So my question, if I change it, if I say a static address, then put 192.168.168.10 dot 5, and I put the subnet mask, which is 255.255.255.0 gateway. And that's where we need to 192.168.10.1. And of course, the DNS is 8.8. Oh, sorry. 8, 8, tab 8, tab 8, tab 8. Okay, so now we need to save it. Oh, did I change something here? Yeah. Oh, that's what happened. Okay, so that's what happened earlier. Stop saving. So, fast forward, go back here, and let's see the status. That's the status, which is good. And internet connection, let's see. Now, can we ping from here, which is, oh. So we got some issues. Whenever I change it, let's see. Oh, it goes back to, so now it should really ping if we go ping, ping of 192.168.10.1. Okay, now it's pinging. So now I'm pinging from this one here all the way over here. So those guys can go to the internet now. All right. So this is part of configuring this device. on auto configuration, or you can put static address if the ISP give you one. Okay, any question at this time? So this is basically we cover the DSL, small business or small routers or small business and homeowner router, how you configure it at home. If you go to Best Buy or any of these stores, you buy a router, this is how you configure it. Any other question?
No,
You guys
sir.
okay? Oh, can you record, please? I guess I forgot. I'll do another one and record it for you. I'll send you one. Let's see. Now it's too late, I guess. Hopefully you take some notes too. So now the other topic we need to talk about, chapter 8. If you don't have a question about chapter 7, we'll move on to chapter 8, which is chapter 8 talks about chapter 8. There we go. Well, this one a little bit different. We're going to talk about chapter 8, which is a DHCP server using IPv6. That's really a different ball game. So that's what we use what we call Slack DHCP. Because mostly on the IPv6, most of the time you don't need really a DHCP server unless if you have an optional addresses you want to give to the client. But most of the stuff is handled by the router. Most of the IP address is handled by the router. And the reason why, because half of the IP address is auto-configured by the server, by the client itself. Because it's part of what we call the MAC, not the MAC address, the host address, which is combination of MAC address and a prefix. That's what we talk about Slack. Slack stands for Stateless Address Auto Configuration. That's what we need to talk about. So let's see. That's the Slack right here. Okay, Slack. Let's see. So one of the objective is to explain how IPv6 host can acquire its IPv6 configuration. It's the same process in a sense, but a little bit different. And why? A little bit different because on IPv4 we use a broadcast. So that when the client boots up, it'll send broadcast and say there's any DHCP server on the network. Now on IPv6 we don't have a broadcast. So how the client is going to get an IP address then? And that's what we need to discuss because they use something called ICMP v6. It's like they send a multicast to whatever group on that network, okay? And that's how they communicate. Now, they explain the operation of Slack, which is basically the stateless address auto configuration or auto configure. So basically, you configure one of the router to provide IP addresses, IPv6 addresses to the client, And also you can use a Microsoft DHCP v6 server, but it's not necessarily unless you put additional services for the client. Like, for example, you want to provide them with different DNS, with TFTP server, with whatever, time server, whatever. So then you add, you put them on a DHCP v6. Or if you want to do, you can do stateful, basic stateful. The DHCP v6 server can handle everything. So they have options basically when it comes to DHCP v6. I mean, few people using IPv6. You're supposed to use it 2010, but more than long time ago, but nobody did it yet. So anyway, so IPv6 was a GUA assignment. That's a global unique address. Global unique address means what? It's pretty much like we're referring to the same thing as a public address on version 4. And that's what we call global unique address. Because in IPv6, we have all kind of addresses. It gets confusing. We have something called link local address. We have the multicast address. And we have the global unique address. So we have all this kind of address. So with GUA, which is global unique address, it's like a public address. That's the address that allow you to communicate outside of your network. And that's what you need to put if you want to communicate outside of your network, you need a global unique address. But if you want to communicate locally, you don't need this address. Your machine are already configured with the link local address automatically. So you don't have to worry about that part. Okay, let's see. You go to these guys here and you go to desktop, IP configuration. You see the link local address is already configured right here on your machine. Yeah. There's already have, and this one, and start with FE80. That's your link local address. This is like the 169 address in IPv4. But if you want, you can configure a DHCP server for IPv6. And you can use IPv6 static on your machine. And you can say, like, same thing, like we say, you can use the following IPv6 address and you put this is the global unique address, blah, 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 all the way to 10. Then notice you don't put subnet mask, you put a prefix, subnet prefix length 64. And this is your gateway. You notice the gateway is on the same subnet or same network as your address. And also you can point it to use a different DNS if you want to. Or if you want, you can click on this, obtain IPv6 address automatically. If your router is configured properly to handle addresses to the client, or if you have another DHCP server in the networks configured with that. So same thing as IPv4, but it works a little bit different. In IPv4, we use subnet mask. Over here, we use a prefix. We say IP address, we say IPv6 address. So you have to mention that. On IPv4, we use a broadcast. In IPv6, we don't use broadcast, we use multicast. And in a DHCP server, you remember the DORA we talked about, the discovery, the offer, the request, the acknowledgement. Now, on IPv6, we don't use this. I mean, similar, but we use something called router solicitation and router advertisement, RA and RS. Okay? So we use different terminology for that. And this is a automatic IPv6 address is selected. The host will use internet controlled message. This is very important to understand this concept. The broadcast on IPv4 is replaced with ICMPv6 on IPv6. So this is replaced the ICV6 because now usually we use an IPv4, we use ARP. You remember the ARP request? They go send because we have the IP address and we need the MAC address. So we use ARP. Well, in IPv6, we don't use that. We use ICMPv6. Okay? And we use router advertisement, message to help auto-configure an IPv6 configuration. So the router is going to say, hey, I'm here. That's what we say, router advertisement. Now, this is the router part, which is router advertisement. On the client side, we send a message. They send a message RS. What's RS? Router solicitation. Basically, they're going to check if there's any router on this segment. Okay? And it say, okay, I'm here. I need a prefix, a network prefix. Once you get the network prefix, the client can configure the rest because all what it needs is the prefix. And after the prefix, we use that something called EUI64. So the prefix basically is going to get the network ID. After you get the network ID, he can use the MAC address, his MAC address, and he can use a little chunk we talked about, the FFE, to insert it in the middle of his MAC address to configure the host portion of the IP address. And that's how it works. Now, before I go any further, any question?
No, sir.
Is that clear or so or what? I see what we have here. So your class end at what time? 10:40. Yep. So we still have 20 minutes, which is okay. So the IPv6 link local address is automatically created by the host when it boots up, boots, and the Ethernet interface is active. And this is what we're talking about: FE80 blah 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 blah. Okay. So that's basically equivalent of the 169 address. One difference, you need to make note of it. So the interface did not create IPv6 global unique address because this is, you need to get it from the ISP. It's not something, and this is going to be global. Global means what? It has to be unique address. So the interface did not create an IPv6 global unique address in the output because the network segment did not have a router to provide the network configuration instruction for the host. Now, the note they're talking about here is the % at the end, which is right here, which is a number at the end of the link log address is known as a zone ID. Zone ID, or maybe the multicast group, where that particular machine belongs to, and this is part of it. So, known as a zone ID or scope ID, and used by the operating system to associate the link local address with a specific interface. Now, the DHCPv6 is defined in the request for comment 3315, because as you know, the TCP/IP, nobody owns it. So it's like an open standard, so anybody can go and modify or change if the committee approve. If it's a good change, they approve it, then they put request for comment number for the approval. Alrighty, that's general. Now, how are we going to assign IPv6 GUI? I mean, not GUI, a global unique assignment. So by default, an IPv6 enabled router periodically send ICMPv6. Okay, this is basically, we eliminate the broadcast, we use the ICMPv6, and we send what? Router solicit advertisement. This is RA, router advertisement, which simplifies how hosts can dynamically create, acquire its IPv6 configuration. So this one here, router advertisement, announce itself to the client. Once the client knows there's a router there with the pre-configured prefix of the global unique address, then the client itself dynamically can create its own IP address using the EUI 64. And host can dynamically assign a EUI stateless and stateful servers. Well, this is like confusing. What do you mean by stateless and stateful? Okay. Stateless, basically, as they say right here, no device is running in the assignment of IP addresses. Okay. So the router will handle everything. That's what I say. Router advertise that message, provided all IPv6 addresses information. That is the network prefix, length, and default gateway. You got that? So let's talk about the router. Okay. Remember how we did on IPv4? We say, okay, we did the DHCP whole, but we send the network address. Is this the network? Okay. But over here, we're not gonna split the whole network. We put basically what? Just the prefix, network ID. And then the rest of the host address is really self-generated by the client itself. And that's what I said. We use the prefix. And also we need to send them the default gateway, the IP address of the interface that the host is connected, or the client is connected to. Okay, so the host uses the IA information exclusively for all internet addresses, including the own global unique address. Now, we can have Slack with the DHCP server, which is stateless. Basically, it's a combination of the two. So the router is going to give them the prefix and going to give them the gateway, but they tell the client, look, if you need additional information or additional IP services for whatever server you want, go to this server right here, the DHCP server. Because the DHCP server is, we call it stateless. Okay, I mean stateful, stateful, and that's what they say. Hosts use RA information to create their own unique whatever, and get additional information from the DHCP server. So if you want additional information like DNS or TFTP server or whatever additional information, you have to contact the DHCP server. Now, you want to fully have stateful, and you want to put all the information on one server, and that's what we call the DHCP v6 server, which is stateful DHCP v6. And in this case, the server will handle everything. And that's what we call stateful. Okay, any question at this point? Let's see. Aha. That's some stuff you need to understand also. How a client obtain an IPv6 global unique address depends on the setting on the RA message. What's an RA message? Router advertisement message, because on the message we have some kind of flag, and it depends on the value of the flag. That would determine if you want to use the stateful options or if you want additional information options. And we have the A flag, which is the address auto configuration flag, signifies to use stateless address auto configuration flag to create an IPv6 global unique address. If this flag is set to 0, I don't need any additional information from anybody. If it's 1, we might need it for 1. And we have the O, which basically we need to have other configuration. And that's what the point for the stateful DHCP-v6. They send them to the server. Okay. Now, manage address configuration, which is the M flag. The manage address configuration flag signifies to use stateful DHCP-v6 server to obtain the global unique address. So it depends on the value of each flag if we're going to use that service or not. And that's what you see here. Slack only, a default. Only use router solicitation. Now, over here, they say use this RA, router advertisement, and the DHCP v6 server. Now, A equal 1, the flag 0, the O flag is 0, the M flag equals 0. So if that's the case, because I don't need other information, I don't need another management, therefore this flag is 0, I don't need. So the only thing, I can use the router to handle everything for me. Now on the second options, the flag equal 1, the O flag equal 1, and the 0. So I'm still using the stateless, but I need some help for other information from the DHCP v6 server, because the other configuration flag equal to 1. If it's equal to 0, then I don't need it. But since this is equal to 1, okay, so I need some information will be stored on the DHCP v6. You get the idea? Now, if the A flag equals 0, that means the router is not going to handle anything. Just go to the DHCP server, and this time will be stateful. Everything you need is on that DHCP server. You get the idea? So really the RA message makes a lot of difference. Let's see, question at this point. No? Right. La, 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 la. And that's what they say. Not every network has access to a DCPv6 server, but every device in IPv6 network needs a global unique address to go outside. So the Slack method enables hosts to create their own unique IPv6 global unicast address without the services of DHCP6 v6. So Slack is stateless service, which means that there is no server that maintains network address information to know which IPv6 addresses are being used and which one are available. So, and that's what's a Slack. That's why I call it stateless address auto configuration. And that depends on NDP, Neighbor Discovery Protocol. So, if you're using Slack, Slack sends periodic ICMPv6 message. So the RA, which is the router advertisement message, every 200 seconds, providing addressing and other configuration information for hosts to auto-configure their IPv6 address based on the information in the RA. So they send advertisement. That's what they call advertisement, router advertisement. Hey, I'm here. They send that advertisement every 200 seconds. So a host also send a router solicitation, RS, requesting an RA. Slack can deploy or deployed as Slack only or Slack with DAV6. So basically you can have the router to handle everything, but if you want to go super management or you need additional information you wanted to give to the client, like when you say additional, like what? Maybe DNS server, a TFTP server, maybe you need to give them an information. For example, if the client wants to boot, they're configured as a Pixie boot, you can point them where to get that image to continue. So you got a lot of services you can put on that DHCPv6, not just to handle an IP address. So other services too. Got the idea? Okay. Enable Slack. So R1, which is right here, R1. If you go to the gigabit 0/1, 0/0/1, as configured with indicated IPv6, which is 200. Of course, you need to remember that the IPv6 is 128 bits. And what you see over there is a prefix, which is /64, which is the network ID. And the rest of them is the MAC address. And also you have at the bottom right here, they have the FE80::1, which is basically the link local address. See that? Link local address. So show IPv6 interface, blah, 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 is going to give you the link local address And it's going to give you the global unicast address, which is this one here. Let's see. Yep. FF0. There's something we need to see, understand what the FE80::1. This is the link local address. Oh, you see the bottom one, what it said? FF02::1. What is that? This is the multicast address. So that means the multicast basically, as we should know, okay, is we send information within a group, okay? Not everybody will receive the multicast advertising unless if you are belong to that group. So I can put like multiple clients or multiple people in the group, then only those people can receive it. So, and that's why they talking about here, join the group addresses FF02::1. See that? So, and it looks like it took the last address here and put it in here to identify that the group belongs to that group, to know what group to send it to. So anyway, so the IPv6 all nodes group. So everybody's connected to this guy here for the router 1 to support. They're supposed to belong to this group, FF02::1. So that's how we start the solicitation. Router solicitation, because the client send, when they send ICMPv6 as a router solicitation, and when this guy send router advertisement, okay, for this guy to receive the message for the request for a PC1 and for this guy to receive the router advertisement, they're supposed to be on the same group, same multicast group. And what's the group number in this case? All nodes group is FF02::1. That makes sense? If you say so. Okay. So show IPv6 interface, blah, blah, blah. You can see the FF02::, which is the group, okay? And this is the pipe, the filter. This is the concatenation section join, because if you want to show IPv6, it's going to give you a scroll, big screen. So to limit it just to this particular section, okay, you can see, you can put this little pipe here, or the concatenation, they call it, to display this specific information. Okay, so I'm going to stop right here and we'll resume tomorrow and we can do some labs, okay? Any questions?
No, sir.
All righty. We'll see you tomorrow. And if you need anything, send me an email. If you have a request or something, let me know. I mean, we'll do our best to have the test on Friday. If not, we'll have it Monday. So we'll see. As long as you need to understand all the material before you take the test. All righty. Have a nice afternoon.